Hello, my people. So today we're going to talk about inverse trig functions. So think about inverse. Inverse is like a do and undo process. So the inverse of add is subtract, and the inverse of multiply is divide. And so think about graphs that we've done for a long time. And so what we would do, you know that a function, you can look at a graph and tell that it's a function if you can do that vertical line test. Do you remember what tells us if the inverse is a function of the graph? Yeah, you go and you do the horizontal line test. Okay, so vertical line test, function, and the inverse will be a function if the horizontal line checked. So does sine x have an inverse? Well, let's look at what it looks like. What does the graph of sine x look like? Well, it's right here. Okay, there it is. So it goes up and down and up and down. So yes, that passes the vertical line test, but does it pass the horizontal line test? It does not, unless we just take one chunk of it. So look at this graph. It like goes up, down, up, down. Where is a chunk that we could inverse? So think about what you know about the mother function of a sine. You know it starts in the middle at 0, 0, and it tops out at pi over 2. So pi over 2, it tops out at 1, right? And then it bottoms out down here. So down, and that would be here, but it's going to be easier if we just go backwards and go to negative pi over 2. So watch this. If I say, what is the inverse graph look like? It's just like that. Do you remember that, so to find the inverse of a graph, it reflects over the line y equals x. So this has done that. It like reflects over y over x. So let's look at some of the like the intricate details of that and what it looks like. So I'm going to go down here. So you know that sine, basically I'm going to draw this super fast, but starts low, goes high, comes down, goes low, up and down. Okay, so it tops out. So this point, this ordered pair right here is pi over 2, 1. And this point down here is negative pi over 2, negative 1, right? Okay, so on this interval, sine x has an inverse, and so right there, I could inverse that, just this little piece from here to here. I could inverse that piece, okay? Now, let's think about what we're going to call that. Well, this is super hugely important. Mathematically, we call that sine inverse. Like, that's how you would put it into your calculator. That's a button that you see. But we have trigonometry to give us words or symbolization for science. So in science, they're not going to say sine inverse generally. They would say ArcSine. And really what that is saying is, what is the radian value that gives you a sine of negative 1? Well, the radian value that gives you a sine of negative 1 is negative pi over 2. What is the sine, like what radian value would give you a sine of 0? 0. What radian value would give you a sine of 1? Pi over 2. So the inverse really takes the x and the y. Do you remember? It just takes the x and the y and it flips them. Okay, so we're going to look at this graph right here. And right now, just from the pink lines to the pink lines, my domain of that is inclusive. My domain is negative pi over 2 to positive pi over 2. Because domain is this way, my range is like this, so my range is going to be negative 1 to positive 1. And it's inclusive, it's including those things. Okay, so now I'm going to do the ArcSine, to do the graph, you swap the x and the y. So if the domain of the original piece of the sine thing that I'm going to use is negative pi over 2 to positive pi over 2, that was my domain. Now, on my inverse, it's going to be my range. And the range on the original function was -1 to +1. So -1 to +1, that's going to change. And now that's going to be my domain. So let's put that here. So this is -1, +1, pi over 2. And negative pi over 2 is kind of under my face on the video. Let's see if we can. So negative pi over 2. Okay. You know that the original graph was kind of going like this. Like this is not exactly in the right places, but it was kind of going like that. Well, then when I flip that over, the line y over x, it's now going to go like that. Is it quite that curvy? No, but do you see how the x and the y are changing places? So that's what it looks like. Let's go back into Desmos and see what the Desmos says about it. See? Okay. Great. So that's kind of what is happening in the graph for a sine and an inverse sine. All right, so let's see. So therefore, where is that defined? Well, I went, let's see, we did originally negative pi over 2, negative pi over 2 to positive pi over 2. Okay, so think about that back on the unit circle. Where is negative pi over 2 at? I'm just going to draw a circle. That's like negative pi over 2 is down here. And you're like, I thought that was 3 pi over 2. Yeah, it is. Same thing. It's kind of like when you first learned to drive. Did you know that 3 right turns equal a left turn? Yeah, this is just like going the fast way, okay, as opposed to taking 3 the other way, 3 quadrants the other way. And this is pi over 2. So this is where this is going to be defined. And so sine inverse is only in quadrants 1 and quadrants 4. Okay, come back to the next video to see more fun things.